Dr. George Guillen hasn't made it in from Houston yet, so we're going to skip down to Dr. Michael Barrett from the Department of Engineering at the University of Texas. And as you can see, our first topic of discussion is the effect of fish and wildlife on bacteria levels.
You guys are awfully quiet out there. Y'all awake yet or what? So while we're getting that up, I'm mainly kind of a general purpose stormwater guy. I do highway runoff a lot and BMP research, and I do a lot of monitoring. And my experience is that bacteria is everywhere, and if it's your job to get rid of it, good luck with that. So we were asked to look at the effect of birds in particular on bacteria levels in streams by TxDOT, who is getting some heat in the TMDL world, particularly in the Harris County area, I think, related to mostly pigeons in that area. So TxDOT funded this, and I'd just like to acknowledge before I get started Mary Jo Kiersitz, who's my colleague at UT, and during this whole presentation, every time I say we did something, you should hear Patrick did something. Patrick Sikora was our graduate student, and he was the guy out there in the rain getting samples out of the creek. So what we were doing basically was looking at bridges and the wildlife that live under bridges as a source of E. coli and fecal coliform, and we wanted to look both under dry weather conditions and wet weather conditions and kind of assess the magnitude of the impact under both of those situations, and look at some of the same questions Mel mentioned about the persistence downstream, die-off or regrowth, the role of sediment as a potential source and reservoir, and also how sediment in the water column will affect the die-off rate of bacteria. So we looked at was Bull Creek. Bull Creek doesn't really look like this today. It's a dry, bone-dry channel, and it's generally a spring-fed creek. And the same thing happened. We did this study in 2009. In 2009, the creek dried up completely too, which kind of crimped us right at the end. And this is the most upstream crossing of Loop 360 if you're from Austin, over Bull Creek. And what lives there are cliff swallows. And to give you cliff swallows are everywhere. We've kind of we've created habitat for them because there are way more bridges than there are cliffs, and so we create homes for them everywhere. And this is bound to be a pointer. So in this picture, just to get you oriented, cliff swallows build in this right angle meeting of like a beam on a bridge and a bridge deck. And so this is the bridge deck, the surface of the road. This is a beam down, and then at the bottom of the beam it splays out a little bit, and then you can see how the feces from the birds is accumulated below the nest there. So they are there, and they are pooping. And there's quite a few. I mean, over this nest, I mean, there's roughly 400 one year and 300 something the next year. And the concern is basically that a lot of them are directly over the water, and so there's the opportunity for birds pooping directly in the creek. And then, as you can see, like most of these are over the land because there's only a little teeny creek. And the reason we took a little teeny creek, by the way, one of the reasons was to try and look at the maximum possible impact. We didn't want like a giant Mississippi River thing where there's going to be so much dilution you couldn't tell what was going on. So we intentionally kind of picked a small water body to look at kind of the worst case scenario. And so for the nests that aren't over the creek, at this site, they accumulate on an adjacent road and rocks and whatever, and then when it rains, there's a potential to be washed into the stream. So the nesting habits kind of determine when the impacts occur the most. And so you've got basically a couple of weeks of an egg in the nest, and then you got about 3 more weeks before the nestlings have their wings and can fly, or feathers and fly away. So you're looking at something in the 5-week period where there's birds in the nest right over the water body, and so that's obviously the most likely time for some impairment to occur. And then after that, there's still tons of birds around, and so if you were to go out now you'd see lots of birds flying around, but they're just not hanging around the nest. And the closest bridge to here with birds, I think, is the overpass on 71 right by the airport, like the cargo exit. They have tons of cliff swallows there. So they're not really looking for a place over water. And so here's our sampling site. This is Loop 360 here, and here is the creek coming down through here. And upstream, just in a little riffle, and downstream, this is Spicewood Springs Road, and all the water in the creek, in low flows anyway, goes through this culvert, and so we have a good opportunity to take samples of well-mixed water and know that we're getting a representative sample. A lot of what we were trying to do was distinguish between the impacts in dry weather and wet weather in those conditions. And the wet weather part's a little tricky because you can get a little bit of rain and it's not sufficient to create surface runoff or, and really convey anything into the creek. And so we were trying to look at a little bit larger rainfall depths to characterize that as wet weather conditions, just to make sure that the flow rate in the creek went up substantially and there was the opportunity to observe wash off from the surrounding upland areas. Whoops. So, in this graph, this is E. coli, and this is just the period when the birds are in town. So you got hanging around, you got the period when they're in the nest and the chicks are in the nest, and then you're back to another hanging around period. So what you see is the X marks are downstream and the circles are upstream, and so you see the highest concentrations that we observed anyway during the period when they're hanging around the nest, and less so otherwise. And so these two lines, this is the geometric mean standard, here's a single grab sample standard, and what you see is the vast majority of samples are below either standard, but there is a significant increase as you go underneath the creek. And you can see it a little bit more. Here is fecal coliform for that same time period. X is downstream and circles upstream, so you can see for almost every event or every sampling period in dry weather that there is a substantial increase, but again, most of the points being below the standard. So the birds on this bridge aren't kicking you into non-attainment. And if you look at the mean numbers, what you see for like E. coli is even when the birds aren't around, so this isn't just talking about foraging, not in the nest, but when they're completely in South America, wherever they hang out, we still got an increase from upstream to downstream, and when they were present, a bigger increase and much higher numbers. For fecal coliform, when the birds were absent, not much was going on, and then an increase upstream. And we looked at enterococci too, and it does nothing. It's like the birds aren't really a source of that bacteria. The other thing that you should notice from this slide is that when we did the tests, which were done at the LCRA lab, which is right next door here, the E. coli was done with a most probable number, where you do a multiple tube fermentation type test, whereas fecal coliform are colony forming units, which is a filtration growth on a medium count the colony test. And E. coli is a subset of fecal coliform, but you can see in all cases here, E. coli is bigger than fecal coliform. So apparently, there is some sensitivity to how you do the test, and if you want your watershed protection plan to show improvement in the water body, then you should switch from doing this kind of test to that kind of test, and you immediately get like a 20% improvement. EPA didn't hear that, right? Whoops. So basically, E. coli statistically higher downstream, no matter whether the birds are present or not. And we took that, and there was another part of this study that was done by UT San Antonio in Kerrville on a crossing of the Guadalupe. And they had slightly different results than we did. It's a much bigger water body, for one thing, and this is like a little shallow stream with rocks everywhere. So it seems like there's enough fecal material accumulates on the rocks and other surfaces near the water line so that you get this continuous source, whether the birds are there or not.
So that first bullet, you mean whether birds are nesting or not?
No, present or not. So, yeah, so even in like December when they're not there, they're still increase upstream, downstream. And so these, like this is swallows completely absent from the area. And this is present, which combines both foraging and nesting. The highest concentrations, again, when the birds are sitting in the nest. And so, I mean, that's kind of a no-brainer in terms of an obvious and immediate and ongoing source. Fecal coliform higher only when the birds are present. So, like this, there is not a statistical difference here, but there is there. And the key thing, I guess, what TxDOT would point out if they get drug into a TMDL stakeholder group is that, look, we're not exceeding standards, the geometric means didn't exceed standards, and we didn't exceed the 25% exceedance on the grab samples. And so, well, the conclusion would be in dry weather, we are definitely seeing the birds as a source and an increase in concentration, but not throwing you into the kind of non-attainment threshold. In wet weather, the story's a little different, and part of that is due to the fact that we didn't have that much wet weather that year, back in 2009, and so this covers an entire period, and so present is, again, foraging plus nesting, and this is when they're completely gone. And the odd sampling thing that occurred was the upstream concentrations when the birds were present seemed to be extremely low, and then the corresponding downstream concentrations much higher, exceeding the either threshold easily. But when the birds were not there, then the upstream concentrations were really high too, and so there's a little bit of some goofiness there, and I think a lot of it's kind of a small data set. So you see the same thing with the fecal coliform. And if you look at the numbers here, when the birds are absent, completely gone, there is not a statistically significant increase. There's a little bit of increase in just the mean concentrations. Nothing really for fecal coliform again. But over here we see a significant increase. So we go from 78 to 688, and that's mainly because when the storms that we sampled when the swallows were present tended to be a little bit smaller storms, and I don't think mobilized quite as much bacteria in the watershed or resuspended it in the stream. The conclusion, I mean, wet weather though, I've almost never seen any water body like a stream or a river that was in attainment under wet weather conditions. There are just so many sources in the watershed that it's hard to, manage it. So when you do the statistics on all the number, everything exceeds the standards upstream and downstream. And the numbers upstream obviously are gigantic already before you go into the bridge. So, I mean, you've already, because of, and this is effectively an undeveloped watershed. I mean, it has a huge park in it, but that's about it. So these are all kind of non-point source, not point source, there's no wastewater discharge, no nothing. And you get gigantic numbers in wet weather. The concentrations were not higher when the swallows were absent, mainly because the concentrations upstream were so high already. And part of this, as I'm talking about here, is this sample size thing. And the other issue is the amount of increase, if you just kind of do a mass balance on the bridge and the water body, in wet weather, what you're seeing really is wash off of bacteria from the ground surfaces adjacent to the creek but underneath the bridge. So in this case, there's a lot of fecal matter on Spicewood Springs Road that goes underneath the bridge, and so when the cars go and track water through there, that can wash off and off the rocks. When you get the water level increases a little bit, then the rocks that previously were emergent are submerged, and so there's a whole new source of bacteria. So one of the questions I think Mel brought up was persistence. So we said, like, okay, here is Bull Creek, and here's our bridge where we were sampling. So we said, well, let's go downstream and see what happens. And so we go from upstream to downstream, and we get our very characteristic increase of concentration right up to the grab sample criteria. And then as we go downstream, which is about a mile or so. We don't really see any substantial die-off. And oddly enough, when we go under this bridge, which are the last two samples here, it has birds underneath it too, but we didn't see a very significant increase for one reason or another. So what we saw was an increase under the bridge and then very persistent concentration beyond that. The second thing that we wanted to look at, Gilliland Creek is in northern Travis County, Pflugerville. It's a 303D listed. It has a TMDL for bacteria. And it's a quite a bit different system because it's effluent dominated. I think there's 7 wastewater facilities, and there were some initial problems early on with their disinfection, and they had to rework those because they were getting a lot of dry weather exceedances. And normally what you kind of expect in most pretty clean water bodies is dry weather be okay and wet weather not be okay. And so we wanted to look at some of the sources there, particularly the persistence and the sediment as a reservoir. So what we did was we went out and collected jars of water from Gilliland Creek, and we collected sediment accumulated on the bottom of the creek in the same locations. And then we came back into the lab and put them in bottles and let them age, and they were stirred and aerated, etc. And what you see is this. Here's the Gilliland Creek water alone. This is Gilliland Creek water plus Gilliland Creek sediment. And if you look at the mean concentrations, you add sediment, you go from 122 to 391. So you've kicked yourselves above the regulatory threshold by including the sediment. And this, it turns out to be, this is quite a bit of sediment. In the creek in dry weather, the mean is 25 milligrams per liter versus 4,000. But the point being, when you resuspend sediment, you're not necessarily going to get that magnitude of an increase, but clearly the sediment in the creek is a reservoir, and resuspension of sediment in high flows is going to increase the concentration in the creek by some amount, and that is a source that is going to be devilishly hard to manage. I mean, I don't really know what you do particularly. The other thing that we wanted to look at particularly was the survival thing. There was an LCRA study done roughly in the time frame of the TMDL development, which showed regrowth that said here was discharges from the wastewater treatment plant, and if we let it age for 2 days, the concentrations go up. And so we wanted to kind of re-look at that. And we did kind of the same study and did not find regrowth. What we found is kind of the conventional exponential die-off kind of curve. And the reason we think that is because in our study, we used actual creek water, and the creek water had all the predators and whatnot in there of a natural system, whereas in the LCRA study it had a sterilized water, so that it was just bacteria with no predators, and so they had nutrients and stuff, and so they could grow, and they didn't see the die-off that we did here. And so again, the message is, without the sediment resuspension, you start with a lower concentration, you get a bigger die-off through time, and if you have sediment in the water resuspended, you start out higher, and you get less reduction through time. So the sediment is a source, and it hurts you by both increasing the concentration and reducing the rate of die-off. So what we saw in dry weather conditions, we saw that E. coli and fecal coliform both higher downstream, whether the birds are present or not. I keep emphasizing for TxDOT's benefit that we did not exceed criteria here. When we got into the wet weather condition, it's just Katie bar the door. The concentrations upstream are very high. From the work in Gilliland Creek, you can see that it could be wash off from the surface. It could be resuspension of sediment in the creeks. There's all kinds of potential sources, and sources that are, just impossible to deal with to the extent that they're natural to a large extent. The sediment is a problem, as I mentioned, and it's going to be and it hurts you twice in terms of the concentration and the die-off rate. So the conclusion, I think, is when we look at bacteria, especially bacteria control in wet weather conditions, I mean, that's an incredible challenge, and the number of BMPs that you can deploy to reduce those concentrations are limited to a certain extent. Cliff swallows are migratory birds. That means you can't mess with them when they're there, but when they leave, you can take their nest down, you can put up like exclusion type features like spikes and whatnot to keep them from coming back. So there is a way, like if you're dealing with bridges and particularly to discourage the birds from nesting on the bridge. But in terms of treating stormwater in general or urban runoff, the number of BMPs that are effective for bacteria reduction are extremely limited. And there's been a move lately towards kind of a more green infrastructure approach to managing stormwater. And a lot of the vegetated controls like swales and vegetative buffer strips are particularly ineffective. And so what you see in terms of structural controls, if you guys are looking to manage bacteria concentrations in stormwater, filtration is pretty effective. And whether it's a bioretention or a sand filter like the City of Austin, you can get substantial reduction. And the other way you can reduce the loading is reduce the runoff volume. So infiltration practices and practices that try and minimize the increase in runoff associated with development is another tool. So basically filtering and reducing runoff volume are really your best bets, I think, in the general purpose, whereas for bridges, at least you can pursue kind of an exclusion strategy of just keeping the birds away. Or bats, if you have bats. So that's my presentation. Any questions out there? Chris?
Gilliland Creek sample, was there only one location on Gilliland Creek and only one time period, or did you do multiple sites or multiple times? I wonder if there's any spatial temporal consistency or related to ambient water quality concentration?
We did most of ours at a single time, and so there was, especially since this was kind of a secondary focus, this was kind of the focus in our study when Bull Creek stopped flowing and we needed something to do. Or Patrick needed something to do. So yeah, so it's kind of a very limited focused part of the study. Mel?
So TxDOT asked you to do this study, correct?
Correct.
Okay, so, but their primary concern was their MS4 permit in the Houston area?
Well, I think
My question is just, how do you take these results and communicate them to folks in Houston area when the stream system's completely different? You know,
right.
Much higher sediment levels in stream under dry flow conditions.
Houston is obviously an issue, and there were a number of people, or at least some people, that during stakeholder meetings brought pictures of, in Houston it's pigeons primarily, zillions of pigeons under bridges, and of course a lot of the Houston channels are these concrete line systems that actually don't have that much sediment in the bottom of them if you get into the middle of White Oak Bayou or something. And but the riprap on the sides, there's a ton of accumulated feces, and so the wash-off there was a concern. And also in the TMDL for the upper San Antonio River, bacteria was mentioned as a potential problem there, and or bridges and highway sources. And we tried to do the same study in urban San Antonio in the impaired parts of the upper San Antonio River and could not find any bridges with birds. And so and we looked a long time. In fact, we looked at every bridge on Gilliland Creek because our preference was to do a study on an impaired water body, and not a single one of those bridges had birds either. So it's not ubiquitous, and the nature changes a little bit depending on how urbanized. And our bridge here had maybe one lonesome pigeon on it compared to the Houston where there's, millions. There's some back here?
There used to be some guidance, and perhaps there still is, that sampling location should be selected 100 meters upstream of a bridge rather than right at or downstream of a bridge. Can you comment on the effectiveness of that in our assessment protocols?
I agree with the downstream part, particularly because depending on the width of your water body, you want it to take a representative sample and you want it to be well mixed, and so you're usually talking like a multiple of 10 times or something of the width of the water body. So being substantially downstream, I think, is a valid methodology to make sure you got a mixed and representative sample. And we struggle with that on, especially the San Antonio sites. Our site's easy, it's only like 3 inches deep, but we were sampling behind a dam in Kerrville, and so the water's deep, and there's some variation from the surface to the bottom, and the velocities are really low, and it was really hard there to know for sure that you were getting a representative sample, no matter how far downstream you were. On the upstream part, I don't think it's really very critical, because I think you can't be right underneath a bridge, obviously, and you need to be out a little bit. And unless there is an obvious and immediate point source discharge that you need to be separated from to get a well-mixed sample, I think you have a lot of flexibility on the upstream side to where you want to go. And what we would look for mainly are places where the flow is concentrated, not a stagnant pool, but where there's a lot of velocity and the stream is constrained enough that you have at least some comfort level that the sample is representative. Am I out of time? Is your other speaker here?
Did y'all look at the conditions that might have affected the fecal matter itself? Like, what was the distance from the bridge to the water surface? During the storm events, I mean, if there were small storm events, then there probably wasn't wash-off or hard scouring of the bridge that built up fecal matter. Or that particular bridge, was there good or poor sunlight? You know, what angle the bridge was, unique effect on the fecal matter itself, or anything like that?
Well, it's in the shade most of the time. And I mean, when you look at bridges in general, not over water bodies, but like overpasses, they tend to not have any vegetation underneath them because there's no water. There's enough light, but no water. So, and at these sites, like on Bull Creek, when you get wet weather conditions, I mean, the creek goes from being like this deep to that deep or something. So but that's enough to submerge a lot of rocks, because, I mean, basically we're talking this kind of situation where if this were under the bridge, you know, you could have accumulation on these kind of rocks like that are just barely emergent, and when the water comes up at all, you know, you have it as another source. So we didn't do any particular studies, but there have been historical studies where people have gone out and collected fecal matter from birds and shown, you know, that it's, you know, that it still contains viable coliform bacteria. So next guy here?
Go ahead and
Are you the next guy?
go ahead and take the question, but we're going to go ahead and start getting the presentation loaded.
On the Bull Creek sample, when we showed the upstream to downstream concentrations, were you also doing the BST sampling on that? Is that what all of your samples are a result of, or was it just recording whole line samples?
We weren't doing any kind of source tracking. It was just counts.
Okay. And on the sediment, when you were showing the...
Our experience on the source tracking is that no one likes it very much, and it always says, oh, it's a little bit of everything, and then at the end of it you have nothing more than you had to begin with, you know?
Right. Okay. And on the sediment die-off, did you take it till where you had, you know, 0 mpm?
No, because, well, we were doing like a 48-hour thing and sampling and coming in and taking a sample every 6 hours, and Patrick was really getting sick of going in there at 3 in the morning, and so 48 hours was plenty for him. Excuse me? All right, thanks, guys.
That was a great presentation, Kirk. I liked your question about the sampling, because that was one of the first things that came to my mind is, you know, where do we need to be sampling if we do notice that there are birds under a bridge. So the watershed impacts, I guess, Dr. Barrett, my question would be, you know, is this something that we really need to be considering as we're working on these watershed plans? You know, did you see a significant enough load where this is really, truly an impact that we might need to address? You know, should we implement BMPs? You know, there's benefits to having those swallows as well, you know, mosquito control and things like that. So do we want to implement BMPs to address these? I mean, do you have any final comments while we're finishing up here?
I mean, they're obviously an incremental source, and if you look at a creek like Gilliland Creek, even though that one didn't have any birds on it, but that is a creek that is just barely out of, over the threshold. And so you can see in that kind of situation, any kind of measure you could do to drop it a little bit would be a huge benefit from a regulatory perspective. In other cases, I think probably not so much, but I mean, my focus would be dry weather initially, because if you have exceedances in dry weather, then you have an ongoing problem with the wastewater treatment plant or something providing that ongoing source. The wet weather, I think, is just impossible to deal with. So my hope is that EPA at some point will distinguish between wet weather and whether that is contact recreation type setting or not. And you also see some permits, for instance, in California, where they use a reference stream in an undeveloped watershed, and they say, well, the reference stream has exceedances on average of 3 times a year, and so we're going to allow you to have that number of exceedances in a developed watershed as well, instead of trying to force you back into compliance under all conditions at all times.
Thank you very much.